Welcome back to the channel, guys. So what I have here are these little USB-C modules, which I picked up a month or so ago off of AliExpress. And what they are is a USB-C power delivery controller. So what they'll do is if you hook it up to a USB-C power supply that has a power delivery programmability to it, these will allow you to program it. And the way they're set up here, you can set it up for 9 volts, 12 volts, 15 volts, or 20 volts just by changing the connection here. So you've got some resistors here, except for the 20 volt one. And you just take a little bit of wire or a 0 ohm resistor and connect over the programming resistor that you want over to this side. They all come set up for 12 volts, but they can be used to put out 9 volts, 15 volts, 20 volts, or the 12 volts that they come with. And you could just use a little jumper, a little wire jumper, if you're more challenged like I am. But very, very small SMD devices like this, it gets kind of difficult. And however, the chip is completely sanded off. So they didn't want you knowing what chip it was, which is, I think that's ridiculous. But, they don't answer to me. But I did search around a little bit on the internet. Now, every other person that sold a module like this on AliExpress and eBay did exactly the same thing. They had the chip sanded down so you can't tell what it is. So I looked around the internet for power delivery controllers, and I found many of them. Some of them very sophisticated, some of them very simple. This is just a very simple little 10-pin IC. And what I found was this. It's called a CH. This is the one here. CH224K. This has got exactly the same number of pins. And when you look at this sheet here, if you look at it, there's two ways of programming it. You can program it by either putting in a binary code into these 3 pins, CFG1, CFG2, or CFG3, in this truth table here to get the different voltages that you want out of it. Or you can program it using a resistor. And if you use a resistor, you can get different voltage out of it. 9 volts, 12 volts, 15 volts, 20 volts. Sounds familiar, right? And to do that, you just put the resistor from CFG1 down to ground. And they give the values of the resistors, 6.8K, 24K, 56K, and not connected. So I'm going to have a look to see, with this little meter here, if these resistance values match what this is, to try and verify it's that controller. Now, the same controller could be made by other manufacturers other than CH. And I think these are the guys who make the CH224K USB module. So I'm not sure. This is a translated data sheet, so I couldn't find the actual data sheet, but I found this one. So they're a very reputable company, a Chinese company. They make good stuff. But anyway, let's try and see if these values are the same. But like I said, this could be made by other manufacturers too. They often have second sources that could come under a different number or different package or whatever. But this is in a small outline IC package. And let's check those resistors. Put this up here on ohms. So the first one should be 6.8K. So that would be the one right down here. 6.78, that's close enough to 6.8 for me. So let's go pop up now to the next range, and we'll try the next one up, the one it's currently set on. Okay, 24K, yeah, that one checks out. Now the one for 15 volts. Right, 56K or 55.9, that's close enough to 56K for me. Okay, so I think that kind of seals it for me. I think we got the right chip here. I'll leave a link to this data sheet down below. There's more pages to this, but it seems like a pretty comprehensive little chip here. It'll do PD3, PD2, BC 1.2, and this being a translation, I guess they kind of got tired of listing off the different protocols. But suffice it to say, it'll work with a number of them. Yeah, and it will support up to 100 watts of power. Yeah, it sounds pretty good. Wireless chargers, laptop charging cables, batteries, small appliances, blah, blah, blah. Okay, well, I'll let you guys peruse that sheet all you want. So now I have here the kind of supply that would be very handy to have on my lab here. So this is a Lenovo Power Brick. They make particularly good stuff here. Now this one here will do, it'll do 20 volts at 3.5 amps, 15 volts at 3 amps, 9 volts and 5 volts, both at 2 amps each. So if I plug this in here, it should activate it. Now I did plug one of these into a 5 volt, just a regular 5 volt USB-C connector without the PD, and it didn't even come on. So it's not going to do that. You need to have a proper PD compliant power supply. So here we go. Let's set this up here to 20 volts and see if we're getting 12 volts out. Yeah, it's supposed to be the plus side here. It's the minus side. Oh, we're getting 9.22 volts out. Ooh, what's happening there? Is that what I have it set up for? Let me get a magnifying glass here. I wonder if that's a faulty one, because it does have the resistor connecting, the 0 ohm resistor connecting up to 12 volt. So maybe this is it faulty? Or is it not working properly? Maybe it doesn't have the right protocol for this particular power supply. Let me try another one here. No, 9.22 volts. That is odd. Maybe this device is not compliant. Is that a possibility? Well, I don't know what I would have that would be. I mean, I have another one of these. Maybe this is not working right. I don't know. Okay, so here's another one of those Lenovos. We'll try this one out here. This is odd, odd, odd. 9.17. Okay. I have some others here. I have this little chickeny here. It also says it has all those different voltages, just at a lower overall power rating of 45 watts. And let's plug this one in here. That's better. Okay, so maybe the Lenovo supply is really not yeah, the Lenovo supply is not compliant with whatever this is compliant with, but the chickeny one is. Okay, so I'm gonna take a couple of these and I'm going to try the other values. We'll bring it back and see if it's working with everything here or not. All right, I'll be right back with that. Okay, I had a little bit of fun over there soldering, and we're back. So this should be at 9 volts, 12 volts, 15 volts, and 20. 20, you don't have anything connected at all. For 15, you have this one here connected. For 12, you have this one here connected. And for 9, you have this one here connected. So let's check them out one by one. We'll go with the 9 volt first. Nine volts right on. And the 12 volts, we already checked that out, but let's check it again. Volts. 15 volts. And 20 volts. Very nice. So they do exactly what they're advertised to do. And I just wanted to get one. I'm going to hook up a couple of wires to it, solder on a couple of wires. And then I'm just going to hook it up probably to a DC load here and an oscilloscope. Okay folks, we're all set up here. I have on here the DC load, which is set up for 15 ohms constant resistance. This is the 15 volt module, so it should output 1 amp when we have the load on. And this is the oscilloscope. I haven't taken any special precautions here with the ground or anything like that. This is just a quick and nasty look. And let's get that scope up there. Okay, I hope you can see everything here properly. Let's move this down, and the scope should be up there somewhere. Right now we're looking at just the ambient noise that we're picking up. So it looks like we've got about 8 millivolts peak to peak, about 7.6 millivolts RMS. Okay, so let's now plug in the power supply. The power supply is unplugged, and we're going to plug it in now, and then it'll be working with no load on it. Give it a second to settle in here. And it looks like, okay, it looks like we're coming in about 220 millivolts peak to peak. It's only about 15 millivolts RMS. It's not very much. Not a lot of noise. And again, this is more the power supply noise, not this. The way this is designed is the voltage coming from the power supply is directed straight out to these outputs, and all this little chip does, depending on how you programmed it, it sends back information about the required voltage to the power supply, which then produces the required voltage. So there's no way this can actually add any noise to what's coming out of here. It's just not that kind of device. It's more of a test of my little Chicone USB-C power supply here. So let's drop that load on it right now, and we'll see what happens. Okay, so the peak to peak's gone up to 280 millivolts. It seems like it's pretty nice to control though, 31 kilohertz. So that would be easy to filter that out if you're going to use this particular power supply to power a device through one of these things. And 32 millivolts of noise, of RMS noise. Alright, here's what it is. These do exactly what they say they're supposed to do. I think they're going to come in handy for me to power up devices that require 9, 12. I don't do too much 15 volt stuff. Maybe something with op amps. We'll see. 20 volts I practically never touch, but you know, never say never. So they do exactly what they're expected to do. The way these work, I don't think this protocol can actually get a USB-C power supply to put out any less than about 5 or 9 volts. I think if you need 5 volts or 3.3 volts, you're going to have to put a buck converter in line with this. And so I put this in, I put the buck converter, and then I put in a noise filter, and you'd have a pretty good quiet power supply that way. Alright folks, thanks for coming out and joining me today for our little module of the month, and I really appreciate your support. I really appreciate those guys who use my AliExpress link to buy stuff. That's every little bit helps. See you in the next video, and in the meantime, have fun with electronics. Bye bye.